We're here at DCS 2016 in Baltimore, and we have an interesting range of lenses that we're hoping to sell to people here. So we've always had a good range of catalog optics. We're proud to announce several new catalog optics this year. But on top of that, we find that there's a big interest today in low value, high volume thermal imaging modules, predominantly aimed at consumer products, but with a number of other applications such as thermography for contractors, security and surveillance systems. The consequence of that is that we need low-cost lenses to address that. And Umicore has been investing in wafer molding technology, which we feel addresses that market specifically and is an enabler for that technology. This year we're launching a 1.5mm focal length lens, which is made using a wafer molding technology. It produces diffraction limited performance on axis up to f1.2. And will work with detectors up to 3.5mm in image circle. So these things we think are enablers for this modern technologies which are going to change the way that thermal imaging affects the world today. So Umicore has a range of manufacturing processes that we've typically used. Obviously Umicore has a long history in conventional molding technologies, and we find that that's very suitable for what's today considered to be high volume. We also have a range of diamond turning capabilities which we use for prototypes. Looking into the future, we're seeing that lenses are getting smaller, that actually the current manufacturing technologies may be reaching some of the limits in terms of the cost reductions they can achieve. And so we've been looking at wafer molding as a possibility to reduce costs in the optics. Now, wafer molding is not a straightforward process. There are a number of challenges that need to be overcome. Clearly, the molding itself is novel. Coating needs to be developed. The dicing process, so that you can get single lenses out of the wafer, is also something that Umicore has invested a lot of time and effort into. But you can see in the lenses that we currently have, we now have a range of sizes from 75mm, fairly large optics, to tiny optics now, 2mm, 3mm in diameter with the wafer molding technology. When you think about how you're going to handle these wafers through your process, it's a lot easier to handle a wafer than it is to handle hundreds of small lenses. So the prospect of this is to keep the wafers intact for as long as possible. So we'll do the molding at a wafer level, we'll do the coating at a wafer level. We can even supply wafers to our customers to enable them to do wafer level processing if that works for them. Certainly we see that the future for thermal imaging and for optics is very bright. Looking beyond our current technologies, we think that this is the start of a process. The wafer molding that we've proven is certainly appropriate for today's volumes and today's technologies. But looking into the future, we think we're going to need multi-element lenses, and the wafer molding technology we think is part of what we can do with that. We're going to have to look at improving our processes to deal with, instead of thousands of optics or tens of thousands of optics, maybe hundreds of thousands or millions of optics. And that's certainly where we need to be in the future. And we have processes and plans that we hope will get us there fairly soon.